Okay, so we start. So in the last class, we talked about our transition from computing values to computing Q values, right? Chalo idhar. So we said that computing values is fine, but computing values does not give me actions and policy. Okay. So we said that we should learn Q values instead. Same recursion, right? Just that we had seen that this max that was here, that comes here, and it has a huge practical impact. So just to repeat that, what is that impact? So I'll essentially repeat that same example that we took in the last class. If I give you an array of size 1 million, okay, and I ask you what is the max, how will you do it? You have to visit all the elements in the array, right? So there is no other way. We have not figured out how to compute a max without really visiting all the elements. On the other hand, if we ask you to compute average, right? So how can you compute average of 1 million numbers? You can add them, divide by 1 million, you get it. Fine. But if I give you an array of size, let's say 100 trillion, how will you take average in that case? So we won't be able to fit it in any of the memories, but you can still do something. What is that something? You can sample. So don't take average of 100 trillion numbers, just take average of maybe a very small sample of it. And that average would still be a representative of the real average. Of course, it won't be the real average, it may not be the real average, but it will be a good representative. Can we say max is a good representative? Let's say of 1 million numbers, I take some 1000 numbers, I take max of these 1000 numbers that I sampled and declare that as a max of this complete array. Is that a right thing to do? So my question is, an array is of size 1 million, I sample 1000 numbers from it randomly and I take max among these 1000 numbers. Can I say max here is the max of the complete array? No. But let's say if I take 1 million numbers, I randomly sample 1000 numbers, calculate the calculate the average. Is this average a good representative of the original one? Maybe, right? We have much more confidence on if it's a random sample, it's a good one, okay? So if I take, let's say instead of 1000, if I take 10,000, if I sample 10,000 elements, in that case you will much better. But can I say the same for max? You still don't know anything about max until you have seen everything, okay? So values had this particular restriction, Q values don't, okay? Now Q learning, as we saw, it has been in news recently, okay? So Q learning, sample based Q value iteration. Now we are doing everything that is sample based. Where is the sample here? Where is the sample here? So receive a sample S A S prime R. So you are in state S, take action A, go to state S prime and get a reward R. Consider your old estimate of Q value. Consider your new sample estimate. Incorporate the new estimate into a running average. Just to reiterate, what is this equation? What is this last equation? Very simple one. It's a simple thing, everybody sitting here knows. Just एक बार बता दो मेरे को. Q of SA is written as 1 minus alpha times the older value of QSA plus alpha times the current value. Okay. If I have just started, my QSAs will not be that much reliable, so it makes more sense for me to keep alpha higher. But as I spend more and more time, so I am using actual samples to compute QSA now, my QSA has become more robust, so it makes sense for me to decrease the value of alpha. Okay. Let's just repeat. Okay, so now कल ये ऐसे ही चल गया था.
Right, first I'm going to execute it by hand. So here's that clip. Everything on the bottom is bad and the exit on the right is good. So watch as I go. As I go, nothing really happens till I receive a non-zero reward. And as I receive the exit from here, in this case it was plus 10, and because my learning rate is still set to 0.5, which is not a good learning rate, it's way too high, but it's good for the demo. If I keep doing this, we'll see that as I leave here, I will learn something about what east does from this state. And you can see I update east. The other actions haven't been updated because I didn't do them. Right? If I go here, let's just do. The learning rate is still set to 0.5. And as I receive.
So to start with, everything is 0. All values of Q, S, A are 0. Okay? Now,
the exit from here, in this case it was plus 10.
So why do we have this value plus 5 here? Just to recap what we did yesterday. So exit value here was 10. Why is it 5 here? No, see, let me go back. You see here this equation, right? So in these equations, they are assuming alpha to be equal to 1 by 2. So if alpha is equal to 1 by 2, okay, now
Alright, first I'm going to execute it by hand. So
if alpha is equal to 1 by 2, the exit value here was the exit reward here was plus 10. Alpha is 1 by 2. What was the older value of QSA? 0. So 0 times half plus half times 10, that gives you this 5.
here is that cliff. Everything on the bottom is bad, and the exit on the right is good. So watch as I go. As I go, nothing really happens until I receive a non-zero reward. And as I receive the exit from here, in this case it was plus 10, and because my learning rate is still set to 0.5, which is not a good learning rate, it's way too high, but it's good for the demo. If I keep doing this, we'll see that as
What will happen now? I mean, okay.
I leave here, I will
What will happen now? So if, okay,
learn something about what east does from this state. And you can see I update east.
why this 2.5? So why this 2.5? And in fact, before I ask this 2.5,
The other actions haven't been updated because I didn't do them. Right?
why this has become 7.5 now? Hmm? Right? So, and why this 2.5? So I believe everybody gets this now. You keep on doing
I go
this,
here,
this
let's just
propagates.
wait for a while. Let's build up
Okay.
enough information about going east.
Bottom up, right?
So it looks like going east is pretty good. What happens if I jump off the cliff? I learned that the fire pit is bad, and if I do it again, I learn that jumping off the cliff is bad.
Okay, so just maybe,
But the fire pit is bad, and if I do it again, I learn that jumping off the cliff is bad. But I can do this all day long, and I will never learn that the start state is bad. Why? I guess the important thing here is when I move from here east, I land in a state which has some good options and some bad options. But when I do my Q update, I maximize over them. And so I only incorporate that 9.8, not the negative 89. So you can see that even though I am jumping off the cliff every time, in fact, the east Q values are going up because they look at the optimal thing. Okay, do that from the start here too. All right, first I'm going to execute it by hand. So here is that cliff.
this
All right,
was a different one.
flash. Okay. Do your best. All right, so what's it doing? Down here is essentially the two angles it has, and that's its action space. This is its state space down here. And I'm going to skip a bunch of steps. And now what you can see is green means high Q value over on the right and high value over on the left. And the little blue lines are the currently optimizing action for each state. So if I turn off all randomness, you'll see that what it's learned.
So we
is
don't
it
go into
executes-
this, we talk about just this one because this has been
Right,
our
first
running
we're gonna
example.
execute by hand.
So tell me a couple of things. How do we update these values? Which equation? This one. Okay. Set alpha, set gamma, and we are good to go to compute these Q values. Okay. So with this, I think these slides are over. So Q learning converges to optimal policy even if you are acting suboptimally. This is called off policy learning. You have to explore enough you have to eventually make the learning rate small enough but not decrease it too quickly. Basically in the limit it does not matter how you select actions. What is Q learning? How is it different from value learning? Right. And how is it different? See, so when you get the optimal values of a state, it doesn't give you the actual information that you are looking for, right? So you still have to do a lot of other computations. In this case, you are getting the policy itself, okay? And we had seen other property. What was that other property? Your policy converges much before your values do, right? So it makes more sense to learn Q values rather than V values, because this will give you what you are looking for, which is a policy, much earlier compared to V values, if at all you will get it from them, okay? Okay. So again, reinforcement learning is nothing but an MDP in which we don't know these things, okay? We had talked about these things. So model free learning. What is model free, by the way? जो कल आए थे वो नहीं. What is model free versus model based? What do you do in model based learning? Right, and in model based, okay, anyone else? See, what is the goal in model based? You try to figure out what is the right T and right R for this MDP, and then you solve that MDP, right? In model free, the goal is not to figure out what is T and R. The goal is to figure out those values directly somehow, okay? So experience world through episodes. Basically take actions in the real world to get answers to all these things. Update, estimate each transaction. Over time, updates will mimic Bellman updates. So initially, how do you write Q? Initially, you write Q as a function of what? Your Q is equal to, no, Q in terms of these updates. How are you writing these updates? Q is equal to 1 minus alpha times Q minus A, which is previous one, plus alpha times the current sample, okay? So initially, like you do in machine learning as well, you initialize with random parameters, right? So you assign your parameters some random value, but then over time you update them. Okay, that similar kind of thing is happening here as well. Q learning, this equation we already talked about, but we can't compute this update without knowing T and R. Instead, compute averages as we go. So this is what we have been talking about. That same equation. Okay, just that this is your sample. Okay. Any questions in this slide? By the way, do attend the session at 3. Okay, no obligations, but I think it will help. So we continue. Right.
So this is going to automatically run Q learning, and let's watch it. So what do we see here? First of all, remember this is a table of Q values, which means for each state that has multiple actions, we evaluate each action separately. Because just because a state may be good doesn't mean all of its actions are good. For example, you can see here that the right thing to do is to walk straight towards the +10, even though all of the squares, in fact, on the cliff have a bad action available. You shouldn't take it. You shouldn't jump off the cliff. Now, of course, this agent jumps off the cliff every now and then. This agent is not following the optimal policy, right? In the optimal policy, you don't occasionally jump off the cliff for kicks. But if you look at the Q values, the Q value, for example, in this state here in the middle on the left, the Q value to the right encodes what you will receive under optimal action. It doesn't encode what you would receive given that you have a propensity for jumping into the cliff. Okay, and that's amazing. It's not telling me how well I have been doing, it tells me how well I could do. That's off-policy learning. Even though you aren't following the optimal policy, you still compute its Q values, which means at any time I could stop bumbling around and just do the optimal thing once I've done this process long enough to have learned it. A couple other things to note. First of all, I have no idea what this square does, because I can't get there. Of course, in reinforcement learning, you're not going to learn about things you can't try out. Secondly, there's some stuff up here that I have never really been in a position to try. So maybe they're great. I don't know. We'll talk about these issues in a bit.
So what was the main takeaway from this particular demo?
You won't be able to explore all the possibilities.
No. See, so what are these values? These are Q stars. What are other values? They might be some QSA, not Q stars. Why Q stars? Because they are the max in this particular state, right? So these are for those actions. Now he mentioned somewhere that it does not matter which action you are taking, you still learn these values. What does that mean? No, see, let me give you the equation as well. Right? So or maybe revisit this, because I believe this is an important demo.
So this is going to automatically run Q learning, and let's watch it.
So what are the values right now? What was happening in the earlier demo? What was the person who was running it, what was he doing in the earlier demo? Following just mainly one policy. What was that? Go from here to keep taking right. Okay, keep taking right, and these values were being updated. Okay, now in this case, what is happening? You are randomly moving, right? So there is no fixed policy that you are following.
So what do we see here? First of all, remember this is a table of Q values.
So a table of Q values, that means how many Q values will you maintain? If I have S number of states, then basically S into A, 4 in this case. Okay.
Which means for each state that has multiple actions, we evaluate each action separately. Because just because a state may be good doesn't mean all of its actions are good. For example, you can see here that the right thing to do is to walk straight towards the plus 10, even though all of the squares, in fact, on the cliff have a bad action available. You shouldn't take it. You shouldn't jump off the cliff. Now, of course, this agent jumps off the cliff every now and then. This agent is not following the optimal policy, right? In the optimal policy, you don't occasionally jump off the cliff for kicks. But if you look at the Q values, the Q value, for example, in this state here in the middle on the left, the Q value to the right encodes what you will receive under optimal action. It doesn't encode what you would receive given that you have a propensity for jumping into the cliff.
So this one, whatever he said just now.
For example, in this state here in the middle on the left, the Q value to the right encodes what you will receive under optimal action. It doesn't encode what you would receive given that you have a propensity for jumping into the cliff. Okay? And that's amazing. It's not telling me how well I have been doing. It tells me how well I could do. That's off policy.
So what was this last statement? We are also learning these values. What does it mean? See, you might be doing whatever. What is it that you update? You see there was R plus max over A star, right? So what you are updating actually incorporates that max somehow in it, right? So it does not matter which policy you are talking about, which policy you are taking, you are always going to update the best one, the max one, right? So eventually, if you do it long enough, if you don't do it long enough, this won't happen. But if you do it long enough, you will eventually update what? Best policy, right? So if you don't do it long enough, let's say if I just did a couple of things by jumping off the cliff, am I updating anything max there? So let's say if we just do this thing, so let me just.
So this is going to automatically run Q-learning, and let's watch it.
So let's say if all I am doing is going from here to here, what will happen? You'll update this for sure. Okay. What else?
All this update the corresponding. So the left and right will be.
But this guy will be updated. What about the rest? They will still remain 0. And what is max of negative and 0? Zeros, right? So you are still, even though you are taking this, but that 0 remains 0. If you start taking these side actions, so if you start taking actions in this direction, I hope this won't start now. If you start taking actions in these directions, these guys will update. And once updated, it won't go down because so you have 1 minus q times the original value plus the new reward that you are getting. Okay. So we come to exploration versus exploitation, but any questions that we have until now? Okay. So Exploitation in this case, in context of reinforcement learning, means keep on doing what you were doing, what you know, you have visited. So something that you have visited, keep on doing that. What is exploration? New states. Explore new states where you have not been. Okay. What are the good points for exploitation? So let us spend some time here. What are the downsides of exploitation? So let's say you have a state space, you have visited everything a lot of time, but you have not, sorry, you have visited a lot of states but not everything. Okay. In exploitation, what will you do? You will not visit the states you have not visited, you will just keep on visiting the ones where you have already been and keep getting rewards from there. Exploration, occasionally visit the unvisited states as well. So several schemes for forcing exploration. Simplest is random actions, epsilon greedy. Every time step, flip a coin. With small probability, act randomly. With large probability, act on current policy. Problems with random actions. You do eventually explore the space but keep thrashing around the once learning is done. One solution, lower epsilon over time. Another solution is exploration functions that we'll see. So what we are saying here, how do you explore? Okay, randomly, or there will be some other strategy. Let's do this.
This one's manual. This is a variant of the grid world where, well, I won't tell you what it is, right? You look at this and you think, well, how should I act? What is this? Well, you've been listening to this lecture long enough that you know this is probably some fire pits on the side of a bridge or something. But for all you know, this is just, 12 doors, one of which has a huge prize. So first of all, just looking at this, you kind of got to try everything. Now, what if we did this? What if we went over there? We did that a couple times. Okay, it looks like we're going to get +1 if we go there. Now, if all we did was exploit, we would continue going left forever, and we would receive a...
So what does it state? If all we were doing was exploitation, what will we do? We will continue going on this side and keep getting rewards, whatever you are getting. Okay?
Bring up +1s, episode after episode. Is that the best we can do? Well, maybe. Right? We could be following the optimal policy right now, but kind of, in some sense, we've got to try other stuff, because we're going to be playing this game for a while. As far as we know, we're going to play it forever.
This is the same, analogy is same. वो जो अपने red and blue machine वाला game था, what was this? Blue was always $1, but red was, with probability 0.75, it was $2, and with probability 1/4, it was 0, right? So let's say if you have played blue long enough, what is that? Exploitation or exploration? Exploitation. But after some point, naturally what you might like to do is, let's go and look at what is red doing. If it comes out to be a 0, probably you will go back to blue, but if it turns out to be a 2, maybe you will keep on playing at red one. Okay, that's similar thing. If you keep on going from here to here, keep getting whatever rewards you are getting, and that's it.
And so we need to explore.
So you need to explore.
Things like, jump off the cliff. Okay, that was bad. Okay, maybe we'll jump off again, just to make sure we didn't get a weird outcome. No, it's looking pretty bad. We might go over here. Oh, that one's good. It's so good that now the other one doesn't even look.
So now what happened in this case? Instead of going there, you started going there, and the rewards are actually higher in this case.
And so now we go here. Now are we done? Well, we've got a lot of things we should try. Now let me point out something, which is that you have a lot of knowledge about the structure of this MDP. So once you see one fire pit, you imagine maybe there are some others. The algorithm has no such concept right now. right? As far as we know, jumping off this cliff will be equally good as the good exit, but in fact it's equally unsuccessful. Well, what about this cliff? We gotta try that too, right? So you spend a lot of time jumping into pits because you really just don't know they're pits until you try them. So you've got to make some mistakes. You've got to explore. But of course you don't want to just be like jumping in them over and over again once you know they're bad. So you don't want to explore randomly or forever. This one's manual. This is a very full. But of course you don't want to just...
So what is the learning from this one? Right. So until you have explored enough, right, there is no point going to these places because there you already know that there are fire pits. But the places you have not visited, like this one, this one, this one, it still makes sense to actually go there and see whether there are some further higher rewards there or not. Once you go there, you have experienced that it was a -1, fine, I don't need to go there, right? What is exploitation? Just go to those states which you have already visited, explored. But exploration means you also need to visit those states which you have never been to, okay? Okay.
Here's the crawler. And now you can finally see what this epsilon control here is. This means 80% of the time we take a random action. That's a lot of exploration. It's not, however, a lot of progress. Now, will this work? Q-learning works just fine with lots of random actions. It just doesn't necessarily work quickly. So I skip some steps. And we've got some big blue. I'm going to skip a million steps. Right? So we compute, we compute, we compute, we compute. And now, it actually turns out that this bot has had a lot of experiences here, even though I fast forward it. Presumably, it should have learned something. Why is it not making any progress? Well, we're forcing it to act randomly 80% of the time, right? If whenever you walked your left leg 80% of the time flew out at some random angle, you wouldn't make fast progress. Okay, so what happens if I turn epsilon down? Let's turn it off. Just let it go. Be optimal. Right? Well, it's not so bad, right? So Q-learning learned the right thing, but the exploration was preventing you from doing it. So there were...
What happened in this case now? So initially, if you saw here, he said somewhere that, so let me just take it
A
back.
couple issues there. It just doesn't necessarily work quickly, so I skip the steps.
So skip 30,000 steps. What does this mean? See, initially what will happen? Initially agent has not explored anything, has zero experience, so it does not know how to really act in this particular environment. What is the goal? Goal is to move forward. Okay? Now, does the agent right now know how to move forward? It does not know. Okay? So, now if you see here, skipping 30,000 step means, so here you have skipped 30,000 steps, here you have skipped 1 million steps. What is this 30,000, 1 million? You train it, right? So instead of showing every step, every Q sample being shown there, change Q values, right? Take, observations from everywhere. So basically you take 30,000 observations more and then act.
We've got some big blue. I'm going to skip a million steps.
So he has, so just look here.
And
Just look at the behavior.
It just doesn't necessarily work quickly. So I skip some steps. And we've got some big blue. I'm going to skip a million steps.
Million steps are skipped.
We compute, we compute, we compute. And now, it actually turns out that this bot has had a lot of experiences here, even though I found it.
Right. So tell me what has happened in this case now. You skipped 30,000 steps, trained a lot. One of the times you also skipped a million steps. That means you trained a lot really now. But it is still not moving because. So let's go back. How do you explore? Randomly. So see, we have seen from that grid world video, it does not matter which actions you are taking. As long as you are taking a lot of actions, you have explored a lot. What will happen? Optimal Q values will be learned. Is this fine? Is this fine with you, whatever I have just said? जो ग्रिड वर्ल्ड में अपन ने देखा, I saw it was moving randomly, but if you make it move enough, then it will learn the optimal Q values. So if the same thing is happening here, right, in this particular demo जो अपन ने भी देखा, it should have learnt the optimal Q values in this particular example too. Then the question here is, why is it not able to step forward?
Here's the crawler.
So you see here, after skipping 1 million,
I'm going to skip 1,000,000 steps, right? So we compute, we compute, we compute.
now here carefully.
And now, it actually turns out that this bot has had a lot of experiences here, even though I fast forward it. Presumably, it should have learned something. Why is it not
So
making
presumably it should have learnt something. That means it has learnt all these good values of, all these good Q values, okay, but still not behaving optimally because, ab
any
suno,
progress? Well, we're forcing it to act randomly 80% of the time, right? If, whenever you walk, your left leg,
what did you just hear? So you are forcing it to act randomly 80% of the time, and only 20% of the time you are using what you have actually ended up learning in this case. Okay, so how should you explore and exploit? What should be the trade-off? So initially explore randomly, okay, but as you explore more and more, your epsilon should decrease, okay. So now he'll make it equal to 0. So epsilon right now is 0.8, he will make it to 0.
80% of the time flew out at some random angle, you wouldn't make fast progress. Okay, so what happens if I turn epsilon down? Let's turn it off. Just let it go. Be optimal. Right? Well, it's not so bad, right? So you already learned the right thing, but the exploration was preventing you from doing it. So there were a couple issues there. Let's see what they were.
Okay, I think that's a right place to stop. Attendance? Paper, I'm done checking quite a few of midterm 1. So अभी कहाँ है एवरेज? But average is pretty low. All right, we go. या तो पहले पूछते यार, अब 3 बजे तो सेशन है मेरा. नहीं, लैब्स में विल डिस्कस, बट एक बार सुनो. गो एंड ट्राई टू डू प्रोजेक्ट 0. ठीक है? इट रिक्वायर्स यू टू डू नथिंग एक्सेप्ट सेटअप करना है पूरा सिस्टम बस. So I will evaluate project 0 in next lab. हाँ? Friday. कुछ नहीं किया उसमें करने को, सिर्फ सिस्टम चलाना है बस.
प्रैक्टिकल एग्जाम है,
बट करना कुछ नहीं है ना,
प्रैक्टिकल एग्जाम है, वाइवा है, सब कुछ इस वीक है।
बट इसमें करना कुछ नहीं है भाई,
Saturday
1 घंटे का सेटअप है वो,
सैटरडे को करना,
एक फ्राइडे अपन लैब में फिर इस बार होते हैं।
सैटरडे को भी तो लैब है।
तुम मत कराना, तुमको 0 ले लेना, बाकी है ना। हाँ
प्रोजेक्ट का क्या
हाँ?
सीन है? प्रोजेक्ट का
हाँ प्रोजेक्ट का ही बता रहा हूँ मैं कि जो 1 सेकंड इसको ऑफ कर देते हैं।